Hi, my name's Andy Collins and I'm Senior Software Development Manager for Resilience Engineering at Amazon Prime Video. I'm going to talk today about our journey intentionally failing systems in production at Prime Video. The reason we do this is we're having more failures so we can have fewer customer impacting failures. So when talking about failures and system failures in chaos engineering, it's almost obligatory in every one of these presentations to quote our CTO, Dr. Werner Vogels. Everything fails all of the time. And the reason he talks about this is if systems fail all of the time, what can we do to actually understand and make sure that the impact of that doesn't have impact to our customers? And one way we can do this is to choose the time when we have those failures. We'd much rather have them when we can control them, understand, get learnings and mitigate them and address those actions rather than when they're customer impacting. So the philosophy here is if we fail our systems first and we fail them intentionally, we can learn from them and protect our customers from those occurring unexpectedly. So if we're having a look at when failures occur and when they're customer impacting, we talk about availability, the availability of our services for our customers. And after security and having a secure system, we consider this the top feature for our customers. Security is a baseline feature. Availability is the thing that customers want after that. So how do we measure availability so we can understand it? How do we set our expectations for a service? And what we do is we identify the service level objectives, the SLOs that we want for each component of our service. And we measure those for each proportion of time and add that all up. So if, for example, we don't meet an SLO for a 5-minute segment, we will consider ourselves not available for that period. And we aggregate that and count that up through the whole time period. So for example, over a year, a 99.9% availability is just 8.8 hours of not meeting our SLO, or downtime or an outage. And for 4 nines of availability, so 99.99% availability, that's just 1 hour of not meeting SLOs for our customers over that period. And the reason we set availability goals and we measure it is so that we can get understanding from it. And availability is an interesting beast. Unlike other metrics which you may want to increase, so for example, profit, or you may want to decrease latency for customers, availability is one of those metrics that you never want to drop. Ideally, you want that to be 100% and you never want it to go down. So the challenge here is how do you work on that metric and how do you make sure that you're keeping it at that level? And the question there is you look at reducing the risk of it going down and the learnings that you can get from that. And one way to do this is to examine each of those events where you have an impact on your availability. And at Amazon, we do this through a post-mortem process. We take a correction of error. We look at the customer impact, we look at the root causes of that error, we identify the learnings from that, the mitigations that we can take in place, and the prevention methods. And we use that to drive best practice across the organization. One of the other ways we do this is we don't just rely on the good intentions. Okay, so we don't just assume that everybody's got good behavior and they're going to address these things and adopt best practice. We can adopt a pre-mortem process, so we can be intentional about this. And we can take our availability goal, the thing that we want to achieve for our customers, and we consider that's the output, that's what we want to achieve. And if we take our input, which is our production services and various different failure modes, we can say, well, let's build a process to intentionally make sure that we measure and understand what our availability is. And we call those game days at Amazon. So we'll do load testing, we'll do failure testing, and we'll use this as a mechanism to reduce risks. And the kind of risks we're looking at is how do you find out what those are? And it's about knowing where those gaps are. And Donald Rumsfeld, the former US Secretary of Defense, had this great quote. I'm not going to quote it all in detail, you can go and look it up, but he pulls out various different areas of understanding risk and understanding about the different areas of risk. And it's all about a knowledge. It's all about you controlling risks by exposing that knowledge. And availability is risk reduction. So we look at the different failure scenarios. We look at the things that we know about, the things perhaps we don't know about. And the idea is to reduce the probability of those risks occurring. And when they do occur, the blast radius, the impact that cascading failures have on other parts of the system. And one way of looking at this, and I've used this as a lens, is a concept from psychology called the Jhari window. So the Jhari window is used in psychology to understand my personal behaviors, how I perceive myself, and how other people perceive me. And you can use this to develop your learnings and understanding about yourself. So for example, at the top here, the top axis is the things that I know about myself and the things I perhaps don't know about myself. And then the other axis is the things that other people know about me, or perhaps other people don't know about me. And you've got the 4 quadrants. So the things I know about myself and are clear to others, the things that I don't know about myself, but perhaps other people do, and they can tell me about that. I can ask them to give me more information about where I behave in a certain way and get some coaching, for example. And then there are things that are known to me, but are not known to others. So I can tell them about myself and about my experience and how I like to work. And the things that are not known to me or others, those are kind of gotchas, the things that are surprising. And those are the risk areas. And we can use that in psychology to understand situations where perhaps we react in a different way and we don't want to behave in that way. So I've used this lens to have a look at that in a systems context for risk. So the Jhari window as opposed to a system view. So I perhaps might be a service owner in a broad microservices network that we have at Prime Video. Perhaps that's one of the components handling billing, for example. And as a service owner, I can understand about my service intimately, the things that I know in the top left-hand quadrant here, the things I know about my own service, and the things I know how it works in a broader system context. And I can use things like pipeline tests, unit tests, all the good practices that we would use there to be able to understand and reduce risk there. Then there are things that I don't know about my service. I'm not completely aware of how that works in a system context, but is known in the system. And I can use things like an operational readiness review there. I can answer typical questions. I can go through, get input from my peers and other services and dependencies I work with. Then there are things that I know about, but I don't know how they operate in the system. We run game days for that. We look at COEs, correction of error reports, things of how my service has operated in a particular scenario, and I can get learnings from that. And then there's the bottom right quadrant here. So the things that I perhaps don't know about how my service is going to work, and the things that I can't see how it works in a system context. And we can use failure scenario testing for that. We can create scenarios, we can inject failures into the system. And the idea here is we get more understanding of how our service, the things that we don't know about our service and we don't know how it works in a system context. And that's what I'm going to talk about the rest of this talk. So if this sounds like chaos engineering, which I haven't mentioned so far, it is. Chaos engineering is the broader principle. And I advocate for this, for experimenting as much as you possibly can, getting as many learning as you can in your test system. But we can't always do this in our test system. Our test system is not an exact match for our production systems. And at Prime Video scale, we simply can't test some of the modes that we want to in a gamma test scenario. Our systems are too big for that. So we need to do some of our testing in production. One of the methods that we've used to do this is we can gate certain features by customers and run with test customers, testing and failure modes that don't impact our real customers in that production system. We can isolate parts of the components. And we've built tooling to enable us to do that for these large scale tests. The key point here is I don't advocate for experimenting in production. What I advocate for is validating, resilience validation. So testing the modes that you have experimented on in your test systems in a production environment. And the idea here is to run those and create those scenarios at the boundary of the behavior that you want to try out and understand where things are. So you'll run them to a certain state and say, that's a known behavior in my production system. I'm confident now that I behave in a certain way and I've checked that and it works. And what I'm going to do is talk about what we've done at Prime Video, the journey we've had over the past couple of years as we've adopted these techniques and that we've used them. So I joined Prime Video about 4 years ago. It was predominantly a video on demand service at the time. And we then moved in 2017 into live sports. And this required for Thursday night football in the US, this required us to build a new stack, a whole bunch of new capabilities and services for that event that was hugely important, and it was risky. So what I wanted to do was have a look at where each of those different components, and could we fail parts of them? How are we resilient to them? And in Amazon, if you look at the best practices, we recommend you have +1 availability zones, you deploy across multiple availability zones. And in Prime Video, what we do is we put our services behind load balancers, and we take an extra 33% capacity across the overall system at peak. And so what we did is we looked at testing this. Could we generate load to generate our peak load at this additional 33 up to that level, and then work to the 33% capacity by taking out all the hosts from that load balancer and seeing how our systems behaved. And we did that for a whole bunch of systems, and we found actually our systems were resilient to this. And our learning was we had additional headroom and capacity to be able to withstand some bumps and additional peaks and troughs of traffic of load we've got. That built confidence. And last year, we launched English Premier League. And this was a huge additional scope increase from what we'd had with Thursday Night Football and other products that we'd launched at the time. And so we had a look at taking our failure injection testing and building out from that. And in this case, we looked at, could we learn from what others have done, like Chaos Monkey, for example, and could we fail different parts of the system? And Chaos Monkey was developed to have a look at the reliability of hosts. We typically don't see those failure modes as being problems in production systems today. What we do see, though, is when parts of the system fail, so some of the nodes, how it impacts the whole overall system. And that's what we looked at testing here. So we got a bunch of the services across Prime Video to adopt this technology so that they could fail their services. And we convinced them and said, well, look, you cycle through a bunch of your hosts when you're putting a deployment. What are you worried about? This shouldn't be a problem. And we ran that testing. And largely we found this was successful, that our resilient systems that were built in place, we could cope with these failures. What we did find, though, is for some of the systems where they were deploying their new artifacts out to hosts, and actually for efficiency, they were deploying on top of the configurations that have got there, rather than replacing the host and putting a brand new host out there. Some of those configurations were stale. And when we failed a bunch more of the services, what happened was those hosts were coming back with newer configurations. It wasn't having a match. And we found a bug in production that we were able to trap early before the launch of this product and roll that out as a problem. We found more than one service actually had this problem, and we were able to trap it before it became customer impacting. So one of the other things we did is we wanted to get up to speed with this. So when we're rolling out a large new product like English Premier League, what we need to do is bring the organization up to learning and maturity in reaction to this. And we do this all the time with training of how we have call leaders and how they respond to events. But what we need to do is bring the whole organization together with a lot of new features and make sure we had a good way of reacting to this. So we adopted a common industry practice of disaster testing. So we set up a dress rehearsal over the weekend. We looked at common failure modes, and these weren't all technical. Some of these were system-wide. So the one I remember from being in the control room is when we went through the list and paged in one of the VPs to say, there was a fight on the pitch. What do you want us to do, and how should we handle this? The cameras are zooming towards that. What should we actually do, and how we should handle this? And he reacted to that situation and worked through that. And part of what we did technically is we had the teams in various different control rooms with their dashboards and their responses and runbooks. We used the system that they'd opted into to fail hosts. And we failed a third of their fleets in various different modes, in combinations, over 2 days. And we failed 10,000 of these hosts. This was super good fun. The teams got into the drill really quickly of responding back, following through a really good pattern, allowing us to have confidence that we could react to this during the event. It was a lot of fun. And what my team learned is when we agreed the different failure modes that we'd have with the service, we'd put those into a configuration. Unfortunately, our system required us to manually enter the data of the number of hosts. And we fat-fingered one of those. We put the wrong number in, even though we checked it. And rather than failing 33% of the fleet, we failed 98% of the fleet. The good news is it proved that fleet was resilient, and we got the resilience in. But I took a correction of error report from my own team to learn from that and build that into my tooling that we do for implementing those failure tests. So what are the common types of failures that we see? So in a microservices network, so Prime Video is built using a modern microservices architecture. Typically, the outage risks that we saw looking back on the prior history of 2018 and 2017 is that when we have downstream services, so for example, service D in this diagram here, what happens when that service fails? Does it cascade upwards? What are the outage risks that we've got here? And we found that these cascading dependencies were the biggest source of risks that we had and the causes of outages. And we have a terminology inside Amazon called Tier 1 and Tier 2 services. So a Tier 1 service provides a direct customer journey. So if you lose a Tier 1 service, it will impact customers. A Tier 2 service, you can lose it and it doesn't directly impact customers. And this is quite a loose and sort of overused term. But the question is, how do you know, if you rely on a Tier 2 service, that it is actually truly Tier 2? And we found some of those services perhaps were classing themselves as Tier 2, but the upper service had got a dependency on that and actually considered it as a Tier 1 dependency. Now, some organizations said, well, the true way of finding this out is you fail those Tier 2 services and then you see what the impact is. That's not a step we wanted to go to. We didn't want to cause that impact on customers, but it is one way of doing this. What we looked at doing is, can you, at load, can you do testing and can you inject failures to be able to understand some of these modes and work out where the tolerance is? And this is good learning in how you can address those systems. So as part of this, if you're understanding these modes, is to have a look at what best practice is to protect against those cases. And the AWS well-architected framework gives a good reference for this. The reliability pillar is a source of huge learning that you can use for this. And we use and advocate this as best practices across teams. So how can you test these? How can you build isolation into your services? How can you use them in practice? And the Builders Tool library as well gives you a whole bunch of examples of how to build these out. So how can you put protection in for caching? How can you make sure that you've got throttling in place so that you don't impact your downstream services? How can you gracefully degrade? Put circuit breakers in. We use these hugely across Prime Video and have contingencies in place. So this is all about knowing what those failure patterns are, and it's about driving out assumptions. So one of the things that we learned is, I've talked previously about correction of error reports, and we found one of the things that worked in Prime Video is, from those learnings from the actions and mitigations that teams took from correction of error reports, how can you say, well, I've fixed that, I've put something in to address this. So for example, I've put caching in place, but how do I know that's going to work? I'm just assuming that works if I don't actually test it. And we found teams adopting this failure injection methodology to be able to prove that the mitigations that they'd put in place for one service to correct an action that they'd seen happen in production is a good method of proving that it actually works. For example here, if you increase latency on one of your downstreams or a dependency in your own service, you can see if you have a response to that. Are you forcing a retry storm or a stampeding herd? And you can check that you've actually got protections in place because you're forcing those timeouts and you can see that they work. And then we found teams that if they'd adopted it from one service, they would actually, this knowledge would trickle over and they would adopt it for their other services and build out a core set of best practices. So one of the other things we did to intentionally protect our services, and this was for English Premier League again, is we'd learned from previous events, we put a bunch of reactive actions in place. So contingencies and mitigations. If this happens, can we pull a lever? Can we make an action happen? Can we take a particular action to avert that problem or take the load off the system, load shedding, for example, or other types of protections. And we found from having a whole range of these, say we'd got 20 or so of these different contingencies and mitigations, it was too difficult to keep these up to scratch, keep them tested, keep them fresh. And so in events, there was concerns with, do we know what the behavior was? And it stopped that behavior of instantly using those levers and taking that action. So for English Premier League, we built some proactive protections. And in this case, we could put a shield up. So we could, for example, take a trade-off decision. Can we degrade personalization, for example, and take a trade-off in the customer experience to increase availability? And the idea here is if you stop some of the personalization actions or for a portion of that customer community, does that allow you to reduce the amount of compute capacity that you're needing to use so that you can effectively protect that customer and allow them to have that availability of services? And we built this so we could control it by groups of customers, in marketplaces, by certain titles. And after using this for English Premier League, at the beginning of this year, when COVID occurred, we saw an increase in traffic on all of our services, an increased demand from our customers wanting to use Prime Video services. And we used these same levers. So we put it in place for a short period of time. We reduced some of the personalization, allowed us to put extra compute in place, and then turn the personalization back on. And again, this protected the availability for our customers. So I want to talk a little bit now about the technology we use for testing. And so we have tooling at Amazon scale. It's just not feasible to be able to run these kind of tests ad hoc. So we have a whole bunch of tooling here that my team owns that runs these load tests, and we run them 3 times a week. We've got automation in place that we run them across the whole of Prime Video, creating us to peak load across all the different availability zones we've got. And we collect the data, analyze those. And to do this, we have thousands of load generators on EC2 instances. We're coordinating those with SQS streams. Those are putting load into Prime Video services, and these load generators are configured in collaboration with the service owners so they understand the typical modes of operation on their services. We use CloudWatch, collect the data and alarms to monitor that where we're going out of bounds, and so we can shut things down safely. And we built the failure scenario testing on this framework. So first of all, we did some work with the teams to manually be able to configure failure injections during game days. So for example, could we fail certain hosts? Could we trigger that? We would ask them during the game days to be able to do that. But that isn't a mechanism, that's not scalable if you're manually asking teams to do things. So we asked them to give us the permissions to be able to fail some of that. That required some security considerations and how we would trigger that. And largely that was successful. But we wanted to build this as a mechanism so we could repeatedly do this and run this. And so we used AWS Systems Manager. We integrated that with our tooling. And this enables us to create opt-in scheduled tests for the teams. And during these game days, we can make sure that we intentionally run the failure tests by initiating Systems Manager scripts on those services. And it's opt-in. The teams create these scripts and allow us to execute them. So what is a successful failure test? What is a successful failure? And we look at this in 2 ways, and we configure this in our system. The success conditions are, you've got to create the condition, the failure scenario that you want to do. So for example, have you increased latency by 10 milliseconds? And we use CloudWatch to be able to monitor this, and CloudWatch Alarm to be able to trigger that. Have we seen that mode occur? Great, good, you've triggered that. Then we set the guardrail boundary of, if this occurs, what is the scenario when it's bad? And effectively, that's the case that we don't want to meet. So for example, if errors go over 5%, well, then that's bad. We want to shut that down and stop that happening. And so we measure these 2 parameters, if it's occurred and if the other one hasn't happened. And we do this to make sure it's safe, and we have this configured in our systems. So on safety, when we adopted AWS Systems Manager as the core technology, we looked at what tools were available to us. And we had to look at being able to use this safely. So we used the feature here so that we can, in our tooling, we can cancel the scripts, we can cancel an operation, and we can fall back when we want to stop a particular operation. So for example, if we've used traffic control to increase the latency, what we want to be able to do at the end of the test or when we cancel it is we want to be able to say, let's stop that. Let's put everything back in the right place. And so we built that out using those features in Systems Manager. So where are we going next? Well, first thing is we want to look beyond Prime Video. We've got a great community inside Prime Video and inside a broader Amazon of understanding chaos testing. We also work with the broader community. It's good for us to be able to understand typical failure patterns and build that into our own services. And as part of the work that we did here when we were adopting AWS Systems Manager, one of the teams in Prime Video built this SSM Chaos Runner toolkit. That's been released open source. We see the benefits of doing that, of sharing more broadly, getting more understanding, and having a broader community of doing that. And we've got various different teams inside the broader Amazon that are adopting and using this tooling. And hopefully, now that this is open source, we'll see that in the wider chaos community, and we can get the benefits back from that as well. And there's a talk there with Varun and Adrian Hornsby, my colleagues, are going to be talking about that in one of the other reInvent sessions. So I urge you to go and listen to that. At Amazon, we also think big. We have a look beyond the initial idea. And so one of the ways we look at doing this is to say, well, if we're doing failure testing today, and we understand that, what would it do to say 10 times that? Or what is the end goal of that? And the question I posed my team is, well, why shouldn't we run failure testing and load testing for every deployment? And this raises some interesting challenges in production beyond what we're doing at the moment. So can we run up a slice of the system? Can we isolate parts of it? And can we do failure testing on parts of that system? How can we do this without impacting customers? And this is the learning journey that we're going through this year of trying to understand how we can build out our systems, how we can work with our customers internally to be able to run these tests without impacting our external customers. So I want to wrap up, first of all, of where we've got to with these journeys and share some of those learnings. So if you want to protect availability, intentionally fail your system. If you're intentionally failing it, you're moving away from good intentions. You're actually making sure that those cases where you think you fail and where you think you've got protections, you know you're doing it. You're taking control yourself. You're moving the unexpected into your own control zone. Experiment as much as you can in test. Do that, get as many learnings as you can, and then validate those in production. Please, please, please don't experiment in production. That's not safe. Even with all the protections in place, it's not safe. Experiment and test, then scale that out to production testing. Plan out the journey. This has been a multi-year journey for us. We've been building up the capabilities. It starts with small footsteps. But if you're not doing this journey, if you're not failing parts of your system and not learning for it, then you're effectively failing. You will fail because you're not protected and you don't know how your system will work. And doing this can be a whole lot of fun. Building the fun into it. Engineers love doing some of this and getting the learnings. It's been super good fun. So if you have any questions, you can contact me. My contact details are here. Thank you for listening. I'm Andy Collins. I'm the SDM for Resilience and Availability Engineering inside Prime Video. You can see my contact details here. If you can please complete the session survey and get back to us, hopefully you'll learn a lot from failure testing. Thank you.